Guys, welcome to Midnight Auto. Today we continue on with our DIY fuse block and we're going to add a relay to control the inverter. Our VCU, our vehicle control unit, is able to control turning on and off the inverter, but for that we need a relay. So I went out and I purchased a bunch of these 4-pin relays. That's what I have here. We only need one, but I bought a number of them. And then I bought a number of these sockets. I think I bought like 5 of these. So far what we've been doing is building up our fuse block by adding these blocks of 4, but we can also add relays to this. This is why I think this is pretty cool. So we can actually add relays over here if we so choose, and that's what I'm going to do. I'm just going to add one more. That will be for controlling the inverter. And I'm not going to bore you with the crimping. I'll do all of that off camera, and then I'll come back and I'll just do all the clicking in and inserting all the wires, and then we'll review on how to wire everything up. As always, we're going to just focus on the essentials here. So my forward and reverse is down here. We're not going to connect it. We're not going to bother with the throttle. We're not going to bother with some other things like the safety box. We'll just focus on getting the inverter to turn on and off via a relay. So let's do that. Okay, so I managed to make some wires here that we can use to add a relay socket and a 4-pin relay to our fuse block. And I'm going to bring you in closer so that you can just see what I'm doing here. Pretty much have a closer look and look at my hands and where all the wires go. And then I'll explain how we're going to add this relay for the inverter. Okay, so first of all, why a relay? Why do we need one, or do we need one? Well, the answer is yes, we need one, and here's why. A relay allows us to avoid sending high current through some sort of device that controls something. Like in our case, our VCU here, vehicle control unit, this is a low voltage device. And in this case, the low voltage side of the inverter doesn't really take that many amps, maybe under 10, maybe under 5, but that's still too much to be sending through the controller, and we don't want to do that. We just want to use our VCU to control the on and off ability of that circuit, but not actually send electricity through it. So we get a relay, and if we look at a 4-pin relay, it has 4 pins and they kind of go together when they're across from each other. So there's 2 that are parallel, and then there's 2 that are perpendicular, right? And I'm going to start off with the perpendicular ones, okay? To me, they sort of form a T, if you will, so it kind of looks like that, you know? And I think of that as 2, as in TO, as in this will send power to something, be it a electric radiator fan, be it an electric water pump, or, wait for it, an inverter. So, and it doesn't matter which one is which. I always think of this one, to me, kind of looks like it's going out, like it's pointing out of the relay. So I always use that one that's quite opposite from all the other ones, that it's not parallel to this one. I use that as output always. And you can do whatever the heck you want. You can use this one as the output, but just be consistent. That's all I'm going to ask. And I'm sure someone knows if this makes a difference, but I've done a little bit of research, and the more I researched and actually looked at actual implementations, I only kept getting more confused because they were either bringing power into the relay on this one sending it out on this one, or bringing it in on this one and sending out on this one. But one easy way to remember these, if you know nothing about anything with 4-pin relays, is that the pins across from each other kind of correspond with each other and do something. So these two, this is what is going to run our high current, is the ones that are perpendicular, and we're going to use this as input and this as out, okay? And all this relay just does is just pretend my finger is just a piece of wire and this finger is a piece of wire, and they're just going to connect my two fingers like this. That's all that relay is going to do on those two pins, okay? How's that for science? And of course, these things have numbers 30 and 87. So you can Google those and see if 30 is really the output. You'll probably see that sometimes it's the input, sometimes it's the output. So we're going to start with these two. And obviously, we're adding this to our fuse block. One of the decisions I thought about and had to make is, do I bring permanent power to this relay or ignition power? We can thumb wrestle over this. It really doesn't matter. But because I can't think of any reason when the inverter would be on in my application where I don't want to drive the car, this inverter is not also a battery charger, so it's not like I'm going to be using it to charge. Basically, when I turn the key to the ignition position, will be the on position, that's when I want this stuff all to come alive and turn on. And so we know that our first row here is what we call permanent power. And right now, all we're running off of that is just our VCU, which is fine, permanent power, the VCU. Then we have things already living on ignition on, and this will go on ignition on. Just keep in mind that the middle row is yellow. This is my ignition on, but so are the last three here, okay? The first one up here, if we remember correctly, is special. This is the start button, okay? That's when we turn the ignition to the start position as if we were starting an engine with a starter. And it's a lone wolf. It's the only one up here. So as you can see, the first thing I decided to do here is just add the other three bus bars because we are expanding. We don't have enough room. So what I'm thinking of doing is that this fuse here will control the signal to the relay, and then this one down here will actually power the inverter, okay? Both of these will run to the relay that will live here, and I'll show you how. But first thing, all we're doing is we're just expanding the center block to these three, okay? And I just decided to use yellow wire for funsies, maybe because of that sticker, who knows. So we're just going to take it here and insert it, and hopefully I'm going to do it right. Okay, so there it is. We just added a bus bar here. It's cut off from the top one. It's only in here. And now what we're going to do is we're going to add a fuse over here on the bottom one. And this is going to be slightly bigger than 1 amp. So I just grabbed a 3 amp. It may go up to like a 5. And I like it because it's a pink or purple one, and we can kind of see that it's a different color. But okay, now what we're going to do is I'm going to take a yellow wire and I'm going to insert it from the back in here. And this is going to run to our relay to the T, but the top of the T as in the input to the relay, okay? So bear with me here. I want to do it so you guys can see. Click, you sucker. Okay. And then the relay sockets came with some of these female terminals, and these nicely just slide in there, and hopefully I'll do it correctly. And you can see from the back of the relay that T here slightly. These sockets are actually combo sockets with a middle hole for a 5-pin relay. I couldn't find any that were just 4-pin. I kind of wanted those for simplicity and less confusion, but oh well. Okay, so then this, get in there. Okay, it clicked. I hope you heard that. Okay, so let's take a look at it properly. I hope you guys can see that that's the top of the T, and this is the bottom leg of the T. This is going to be our output. All right, so all we did right now is we just brought in power to the relay. Actually, what we need to do is insert that fuse. So I'm going to do that now. Okay. So right now, power from the middle and the bottom 3, ignition on, is actually going to the top pin of that socket. And I'm holding this relay like that so you guys can see that it's coming in on this pin right now. This is how it's going to go in there, okay? So we're bringing power in, and now we're going to just continue on out to the inverter. Okay, so this is my stock wire harness for the inverter. I'm going to just go ahead and plug it in here. Okay, that clicked nicely. We are concerned with 2 wire pairs. There's a white and black stripe wire pair. This is actually 2 of them. So this is going to be our ground. This is going to get grounded when we're ready to the bench power supply. But that's how we'll power the inverter. And then there is this 2 green wires that actually on the OEM implementation run into a red wire, believe it or not. But I'm just continuing it on as a green wire. Okay, so this is just a long green wire that if I put this setup in my car, hopefully will reach from under the dash to where the inverter sits underneath the hood of the car, right? Okay, so this now needs to go to the bottom of the T because this is our output. And it would have been nicer if I kind of thought about this and made this wire green also, just to help you guys out with the conceptual. But it is what it is. You know, anytime I try to sort of standardize on something, it just drives me bananas. Okay, so we are going to put it from the back into this one here. And hopefully I can do this correctly. Am I doing this correctly? Okay, so you guys can see. All we did was we built that little T because this is power to the inverter, okay? But now, if we were to put a relay in here and connect all the wires to the bench power supply and turn the key till the cows come home, nothing would happen, okay? Nothing would happen because we're only 50% done with our relay setup. We connected, let me tell you here, pin 87 as our input to pin 30 as our output, okay? So this is what's going to be doing our workload. This is the muscle of the relay. So then we come back to the relay. We did that one and we did this one. Now we have these 2. And these 2 now we get to talking about positive and negative. So Damien tells us that the inverter controls the relay as a low side switch, okay? And low to me is synonymous with ground or negative, okay? When it comes to DC.
We then come to these 3 signals here: inverter power LS switch, main contactor LS switch, and pre-charge LS switch. So first of all, the LS is shorthand for low side. Low side means in this case that we are switching the ground of the device that we wish to control. Now, if you don't understand what that means, I'd suggest having a look around the web and or YouTube, and there's some very good descriptions of the difference between high side and low side switching of relays and other loads in an automotive setting. The inverter power low side switch is designed to switch a relay coil that then controls the 12 volt feed to an inverter, such as a Nissan Leaf inverter, a Lexus inverter, a Prius inverter. It's the other one I've been messing about with, the Mitsubishi Outlander inverter. So this signal here allows the VCU to control the 12 volt supply to an inverter, powertrain, and various components like that.
And I'm the last person on earth to explain to you low side switches, but you can control a switch or a relay either on a positive wire signal or negative wire signal, and we are choosing to use the control as the negative wire. So if our control will be a negative running from the VCU to the relay, essentially the zombie will be providing a ground to our relay. This is a electronic component, and I always say that it's not like a broken record. And electronic gizmos, components, need power, and in the DC world that comes from positive and negative. And so we will provide ground to one of these pins, and it doesn't matter. If you guys want to school me that it does matter, please do so. But again, I've done quite a bit of research and saw a bunch of implementations in real life, hands-on. And every time I thought I found a standard, the OEM guys would flip it and make it opposite. So I don't think it matters. But these two, one of these has to be positive, one of these has to be negative. If the wire to the VCU is our ground, then the other one needs to be positive. So what we do is we use our second wire here that I made, and this will be our positive because the VCU will provide the ground, so we need to provide another positive. The first one up here is a positive, and so is this one, but they serve different purposes. The top of the T is the muscle, and this one of these will be the brains. Okay, so we're going to add a fuse in here, a 1 amp fuse here, and connect it to this closer one just because. Okay, so let me pop this in here. Hopefully I, again, do it semi-correctly. Will you click? Clicked. Okay. And then, I hope you guys see this. So this, because this is our control signal, just needs 1 amp. So we'll pop it in here. Okay, so this fuse is for the control signal to one of the parallel pins on the relay. So if we're looking at like this, it's coming into this one because obviously I have to flip it around, but it doesn't matter if it was coming into this one or this one. One of them has to be power and the other one has to be ground. Okay, so let's just muddle through the last one. The last thing we need to do is we're going to add a ground. So this yellow is actually a ground, not my proudest moment of choice of color. I should have picked something like maybe black or brown. But anytime, again, I try to standardize on colors, like I find some white wires that are ground, so you get the idea. Okay, so we just feed it in here. Click. Okay. All right. There it is. So again, we have our T to provide power to the inverter, and then we have these two to provide the control signal. So now we're going to pop in our relay. okay, like so. And we can add another one on top here. And then we can continue building these out just like we did our blocks to infinity. We can just keep adding and adding right here. Okay, so I bought like 4 or 5 of these so we can continue adding, right? But that's what I like, why I like these. These are just great for prototyping, okay? You know, you don't have to start with a fuse block with 24 fuses and only use 10. You know, you can start out with 4 and then keep adding. And same with the relays. Okay, right now I can only think of 1 relay, so why do I need a block with 4 or 6 or 8 relay sockets? And I get that some are waterproof and have these nice plastic covers and so on, but this is for prototyping. Okay, so now we need to connect the other ends. So the yellow wire that comes off of our relay, you know, control signal, this is the ground, and it goes to the VCU, and it goes to pin 32. And if we remember our pins, so it's 1 through 14, 15 through 28, and then this would be 29, 30, 31, and 32. So 29, 30, 31, 32. I think I got it in the right spot. So as I was saying before, you can pretty much drive the car just on what I call the B connector. See how there's sort of 2 of them here? So I keep calling this one the A connector, this one the B. This is the only wire that needs to be on this one really to drive the car. Although you don't have to power the inverter on with the VCU, but it is recommended. And if I'm going to make some videos and share with people how to do this, then let's try to do it correctly, right? And the way that the manufacturer recommends. So we are going to power our inverter with the VCU or control it. Okay, so we have that. And now we need to do all the rest. So all the stuff you've seen before. So let's do that. Okay, so now it's time to bring out the bench power supply, which you've seen before. So I'm going to try to scooch this so that we can see what's happening here. And first thing we're going to do is we're going to take care of some grounds. So I know I have a ground to the inverter, and I know there should be another ground to the VCU. Okay, so I think we just have 2 grounds in this situation. So let's do that. So this goes to pin 55. We've been over this before. And I do have the bus bar on that wooden block, but that's for a different setup. So I'm going to still try to do this with the terminals here. Hopefully it doesn't make me look foolish. So the bench power supply is going to supply a ground to our VCU on pin 55 like it's done before, and it's going to supply a ground to our inverter using the stock wiring harness, 2 white wires with a black stripe. We will set up sync serial, and first we just got to do the power stuff. And then what we need to do now is supply all our power to the fuse block. So the first thing here we have is a red wire, permanent power, these 4 here. So this is running to the bench power supply. And then what else do we have here? We have our power to the ignition. So this is the input to the ignition, which will eventually become ignition power as well as start power. So this is just the input there. So I'm going to connect those 2 next. I think those are the only 2 that need to run to the bench power supply. Okay. Okay, so the top one here is permanent power. So that's this wire. So that's going to run to pin 56. Then we have, which I believe is the ignition. So ignition is on pin 15. And then, so that was ignition number 1 here. Okay, so let's run. And this part here we've done before, so if I'm going too fast or if you can't really see it, just go back to prior videos. So this is on 52, 56, 55, 54, 53, 52. Okay. And now I just have to go in and rewire this sync serial here. I swear I'm wearing out those pins. Okay, we're concerned with permanent power, ignition on, start, inverter control, and inverter power via the relay. And yeah, sync serial. Hopefully you can see this. This is made with zip ties. So it's one zip tie goes all the way around them, and then you put the other zip ties in between. This is 4 wires, so it takes 4 zip ties. Well, why am I sharing this? Well, this keeps them in order. See, it keeps these wires in order, and this is how they get wired into the VCU, okay? So then I know it goes white, black, white, black, white, black, white, black, and all I have to do is just bring it to my VCU. This is advice for bench testing, farting around, right? You're not going to be wiring and rewiring this like me, like this complete fool constantly, right? But this really helps. It takes the guessing game out of it and the thinking out of it. And the less I have to think, the better. So this is 16 and 17. And then white, black on the next one. 18, 19. And then the next one. And it's just white, black, white, black, white, black, all the way across. Damien did a really nice job of putting them together. And of course, I stuck one under the pin. That bit as before. Okay, so that's all of our connections. And we only did the sync serial so we can get some sort of a feedback in the laptop. And see how, what I meant, see how they go kind of parallel with this, with the zip tie dividing them. I just love zip ties. They're so great. Okay, so this is our fuse block. Bench power supply. Let me bust out with the laptop here. Yeah, let me bring out the laptop and we'll see if we did it right. So fingers crossed there's no black smoke. Fire this up. So you guys can sort of see the lights flashing. I don't want to move anything. I don't want to get bitten by any shorts, anything shorting out. All right, so the VCU has permanent power. It should be advertising its network. So we're going to jump over here. And we have FairyLink connected. So now we jump to the Hubner thingy. So right now, op mode is off. And then we've learned, oh, I've added a feature to this for those of you who haven't seen the other video. Now we can sort these. So now they're sort of sorted alphabetically. And if we click on the name again, now they are reverse alphabetically sorted. So that's kind of cool. And so now if we scroll down to the T's, we can see that whole T15 thing. Okay, so it's T15 and it's off. And so how do we tell, when the inverter turns on? Well, first we need to turn on our ignition. And before, when I was complaining that the op mode here doesn't change when we turn the ignition to on. Well, the T15 is the ignition on. So we watch for that right here. All right, so let's give it a try. Can you guys see me twisting the key? Sort of. Okay, I'm gonna refresh and see. Okay, T15 is on. So that means ignition is on. Now, how do you tell when the inverter comes on? So we don't have to have high voltage going to the inverter to just turn it on, okay? And there's a couple ways to tell when it's on. The first one is that there is actually inverter status, I think. So there's INV stat, and it says it's off. So the inverter won't turn on until we actually click the run. So there it goes. I'm going to go ahead and refresh this. Okay, so here's our inverter stat. Obviously that was on already. And right below it, inverter status is on. Okay, it is actually turned on. We can sort of do some cheating and watch to see if our amps draw rises. It did rise because now it's powering the inverter. I mean, it's still minuscule here, 1.5 amps, but I hear it now. The fan, I think, kicks in that bench power supply. It's working a little bit harder. So one of the things we can look at is inverter status comes on to on. That's pretty obvious. But there's also a couple other things we can look at here. So we can look at, I think is it temperature, heat sink, or something like that? Well, let's sort on it, shall we? Spot values, name, and where is it? There it is. So see how there's a TMPHS, temperature of heatsink. I think what the Greg is going to try to tackle next is maybe writing out these parameters, actually spelling them out for people so we don't have to explain what they are. Now, whatever I'm doing here is, it's all aesthetic. It doesn't change anything in terms of functionality. It's just little tiny things, I'm doing to just make tiny little improvements. But this is the temperature of the heatsink inside the inverter, and below it, TMPM, obviously, is temperature of the motor. Well, the motor is not in this setup. The motor is in my car, but I think I don't know if that's an erroneous reading here or if that's just the default or ambient, whatever it is. I don't know. I mean, I doubt it's negative 27 Celsius, so maybe that's some sort of erroneous thing. And there's one more thing I think there is. One more parameter. I think I saw it. Inverter UDC. So this is inverter voltage, and I know it says a -2, which is, I guess, maybe erroneous, but I think this will be 0 if it's off. So let's remember some of these values, and let's go ahead and turn off our inverter and see what happens. I don't know if you guys can hear it, but my bench power supply is no longer making noise. Hopefully you can see that. So without the inverter, see how my amps here drop to 0.14? It used to be like 1.5 before, I think. Okay, so let's refresh and look at the inverter UDC. So inverter status is off. Inverter UDC says -2, so that didn't change. I wonder if that changes if we actually turn off the power and then start over. I'm pretty sure that usually says 0. Well, let's go further down since we're here and let's look at temperature. Okay, so Okay, interesting. So temperature of the heatsink is 33. Temperature of the motor is this. I think these values will zero out if we kill permanent power. Let's try that. Okay, so I turned off permanent power. This is again just for Workbench. And one thing I want to say, if I haven't said it already, all this tinkering, all this time we're spending on this interface, you're not going to do any of this. It's just set it and forget it and drive your car. Okay, you're not going to be in this web interface daily, weekly, monthly. Okay, you're gonna spend some time to initially set it up, and then it's gonna be forget about it and never look at it again. Okay, so but this is just for us during our geek out phase. Okay, I think we're still connected. Let's see if we can refresh if we're really back here. Okay, so I just refreshed. Let's go to spot values. Let's sort and let's pay attention this time. Think I counted there's like 80 spot value parameters. They're not numbered. Um, okay, so we want to go to like INV. Yes, okay, so I'm not crazy. INV stat is off, and see how INV UDC below it is 0? So it's 0, and then it goes to -2, okay? It may be an erroneous reading, but it's like trying to read something. Okay, and now let's go to temperatures. Okay, so see, ignition is off, and then temperature of the heat sink is 0. And then wasn't it like 33 before? Now I don't know again why the motor one is -27, but let's just focus on the inverter for now. So the temperature is at 0 here, and it will go to 33, and then the other parameter um, was up here again, INVUDC. This is 0, and it does go to -2. So my only question would be is why they don't go to 0 when we turn off the ignition. Okay, why do we need to sort of turn off permanent power to refresh these back to 0? Maybe I'm missing something. I don't think it's just a website refresh, but let's repeat the exercise, okay? So inverter UDC is at 0 and inverter stat is off. So what we're going to do is we're going to just turn it all on and go to start. And now we're going to refresh this. We're going to refresh it. Spot values, sort by name again. Let's take a look-see and see what it says. Okay, so inverter status is on. Again, inverter UDC. So U is pronounced V, and V stands for voltage. So this is just physics, man. Inverter U voltage of direct current. And op mode went to run. It's all good. Now let's look at our temperature. So temperature of the heat sink is 33 Celsius. What is that in Fahrenheit? I cheat over here on my wall. That's like uh 86 something Fahrenheit, maybe. It's about right, probably. Like, it's hot outside. It's like in the 90s outside. This is cool. Okay, and then I don't know why the motor reading is here. I mean, we don't have the sensors hooked up, so maybe something's wigging out. Okay, at this point, let's turn off our car. We're gonna turn off our ignition. Let's refresh. Okay, so right now, again, let's do spot values, sort by name. I think I might have an idea. What were we looking at? Okay, so this ID inverter UDC, it's a -2, and I bet you the temperature stayed at 33 as well, right? Oh, another thing I want to show you here is that another thing we can sort on, still under spot values, we can sort on the first two columns, so either by name, so alphabetical or reverse alphabetical, but also I made it so we can sort on value. And you might say, well, what the hell we want to do that for? Well, it kind of groups things together. So so here, the inverter is a -2 and our temp for the motor is negative. So those are grouped. That's kind of silly, but let me show you another one. So like if we want to look at values, like here we have the temperature of 33. Anyway, sometimes you want to just see the ones that have values. So I just want to show you that sorting spot values on value works. And it's also click it once, it sorts it one way, click it a second time, and it reverse sorts it. So let's go back to that temperature setting. Okay, so temperature heatsink 33. Here's what I'm going to do. I'm going to turn on the switch to the ignition on position. I'm not going to turn on the inverter. I'm just going to turn the car back on. Okay? And I'm going to refresh. And let's go to spot values, sort. And I'm going to go down to that temp. No, it didn't zero out. You can tell that the ignition is on and the temperature stayed, but the inverter is not on right now. So I have small beef with this situation. I probably don't understand it. I'm gonna call it, instead of beef, I'm gonna call it veal. I have veal. Is that what a baby calf is called when it comes to consumption? Okay, well, our mission is accomplished. Our relay does turn on the inverter. That's what we wanted. We kind of went down a rabbit hole of some values here of not maybe resetting or zeroing out. Um, Let me know in the comments if you've seen that or what do you think is happening. As always, I really appreciate you guys watching, putting some Chuck Norris jokes in the comments, and we're one step closer of putting all this jazz in the rabbit and going to get ice cream. So stick around.